on on projectile motion. That will be our discussion for today. It is a special case of uniform of motion in 2 dimensions and 3 dimensions. Tomorrow we will discuss two examples of motion in 2D and 3D. We have uniform circular motion and relative velocities as another important consequence of motion being relative. But today we will discuss projectile motion as basically a 2-dimensional motion that's for which the x component is unaccelerated, therefore constant velocity. For the y component, constant acceleration, the particle is in free fall. Okay, so without further ado, let's have the set of objectives. Our outline, wala tayong outline kasi basically we will discuss one topic, which is projectile motion. So I don't need an outline today. But for the objectives for this discussion are the following. First, we describe the characteristics of a projectile. So what are the assumptions needed for us to say that the something is called a projectile, or the motion of something is or the particle is in a projectile motion. So ano yung mga assumptions na yun na kailangan natin para masabi nating projectile ang isang projectile? And then, discuss the consequences of the independence of vertical and horizontal components of projectile motion. Apparently, if I remember correctly, it was Galileo who discovered that there is some independence in the vertical and horizontal components of the projectile motion. Therefore, it can be analyzed separately. And we will see that the kinematic equations are connected by initial velocity and time, but the vertical and the horizontal components of the velocity or of the motion are separated, or can be separated, or can be analyzed separately. Okay? And then, of course, we will apply what we learned from this topic to solve problems involving projectile motion. Are there any questions so far? May mga tanong ba? May mga tanong? Are there any questions? Walang tanong? Wala? Wala. Okay. Seems na wala. So let's have a review. So naalala nyo si free fall motion. Remember your kinematic equations for free fall. Basically, what you just need to do there is to replace your acceleration by g. In that case, you have negative g here because the equations here assume that g is positive, and we are in a coordinate system where the downward direction is negative. That's why these are the forms of the equations that we have. Okay, we will be using this in analyzing projectile motion, specifically in the vertical direction of the projectile, of the motion of a projectile. So remember these 4 equations. We will use especially this one, and sometimes this one. Okay, sige. Now, so yan. So what's projectile motion? Of course, yun yung una nung tanong, no? What's projectile motion? Projectile motion, a projectile is any body in 1 dimension, 2 dimensions, or 3 dimensions that is influenced by gravity only. So in that case, for a particle to be in projectile, the only force that is acting on the system, on the particle, should be gravitational force only. Hence, for example, if you have a baseball thrown forward, mas gagamitin natin yung 2D case for projectile motion. Your 1D case is basically free fall. Free fall is a special case of projectile motion in 2D. Kasi doon, walang velocity in the horizontal direction. But for here, since the only force acting on the baseball is the acceleration due to gravity, then this ball here is an example of a projectile. Okay? Questions? May tanong ba rito? So the only force acting on this, and therefore the only acceleration that will be exerted on the baseball, is the acceleration due to gravity. We are assuming here that the baseball is not thrown in space, but rather thrown in ground. Wala tayo sa space. Okay? Sige. So here are some assumptions when we say a particle is in projectile motion, I mean. The first one is, of course, you will neglect air resistance. There are some analysis that involves air resistance in the calculations, but it's more complicated. That's beyond the scope of Physics 71. For now, we will assume that in our problems, that air resistance is negligible. Para mas simple yung analysis, mas simple yung equations na makukuha natin. Because also, it contradicts our definition that only gravity acts on the particle. Kasi kung may air resistance na dyan, the air resistance will exert a force proportional to the power of velocity. based sa mga natutunan ni Newton. In that case, hindi na ganun kasimple magiging dynamics nung projectile mo. Okay? So yun, first we neglect air resistance, and then second, we ignore the curvature and rotation of the Earth because we will see in Newton's laws, but there's a main reason, there's a more fundamental reason ba't ini-ignore natin yung rotation ng Earth. But for now, ang sasabihin ko lang is, mag-iiba kasi yung forces na nag-a-act sa isang projectile if the Earth rotates. Iba na yung magiging acceleration due to gravity mo. Number one, it depends on the latitude. Number two, meron ka ng additional forces that you need to consider when you have when you have a rotation in Earth. So, dyan nalabas yung Coriolis force, dyan nalabas yung centrifugal acceleration, etc., etc. So, for now, let's simplify our analysis to only include gravity as our force. May tanong ba doon? It becomes more complicated as we increase as we, yun, mas naging complicated pag mas naging real yung analysis, yung modeling. Okay? Questions? Questions? Wala? None. Sige. Now, so in that case, ganito yung magiging itsura niya. So let's say, for example, we have a projectile that is launched with initial velocity v naught at some angle alpha naught relative to the horizontal. So gamitin muna nating convention is alpha, or the angle between the projectile and the initial velocity and the projectile is some angle alpha naught. Between the projectile and the x-axis is some angle alpha naught. So mangyayari dyan, so of course, kapag isipin mo, magkakaroon ka ng, the particle will trace a path, imaginary path in space. That imaginary path is called your trajectory. Nakwento ko na to kahapon regarding the position time, the difference between xt and the displacement vector in 2D and 3D. Dito, makikita mo na yung paano ang interested tayo dito is paano nagto-travel yung particle in space. Di natin masyadong tinitignan ngayon since nasa 2D na tayo. Ano yung dependence ni y tsaka x in time? Di mo naman makikita yan. Wala ka namang stopwatch sa mata mo para makita kung ano yung time na nag-take dun sa particle, di ba? Unless you measure it with a stopwatch, you cannot see it. So the trajectory looks like this. We will assume later that this is some alpha naught, where alpha naught is the angle between v naught and x. Okay, so the only force and therefore the only acceleration here is the acceleration due to gravity, which is downward. Okay, now ang nangyayari to, projectile motion is one of the hardest problems in the history of physics. Marami siyang complications in a sense na, well, how do you analyze the system? How do you analyze the system? And it's boggling a lot of scientists. We will see that when we go to Newton's laws, to the historical context of Newtonian mechanics. Bakit importante yung projectile motion problem? In showing that Galileo is correct, and therefore it gives you your usual kinematic equations, etc., and so on and so forth. So ang bottom line dito, hindi siya ganun kasimpleng problem before. But apparently, it turns out that like, for example, if you do an experiment for a particle in free fall and a particle in projectile motion, therefore this is a particle with some initial velocity v naught, let's say may initial velocity and to the horizontal direction. Apparently, you will see that the x component will move at constant velocity. But the y component, yung kapansin niyo doon, lumalaki yung spacing between between same time to tinik, tapos iba-iba yung spacing lumalaki. Ibig sabihin, nag-accelerate downward yung particle. So, consider the stroboscopic photograph shown. So, it's taken at multiple times. So, successive images are separated by equal time intervals. Ito nga yung sinasabi ko na pare-pares yung time interval yan. And you will see that, so, yeah, of course, you know that red ball and yellow ball, they are done simultaneously, and at any given time, both balls have the same y position, y velocity, and y acceleration, despite having different x position and velocity. So, ibig sabihin, in a nutshell, magkahiwalay ngayon yung horizontal component at vertical component. Therefore, you can analyze them separately. That's the hallmark of Galileo discovering this. This is, I believe, it's Galileo who discovered that independence in the x and y components of the velocity, of the of a particle in projectile motion. Pwede mong i-separate yung analysis ni y direction at saka ni x direction. And it turns out that for the x direction, it's constant in velocity. For the y direction, it's constant in acceleration, assuming that the particle is near the Earth. Okay. Now, so alam na natin yung equations na yun, di ba? So, for we can, in that case, since independent ang x at saka y, we can divide the analysis into two. One for the x direction, the other for the y direction. And in that case, for horizontal motion, the velocity is zero. The velocity is constant, and therefore the acceleration vanishes. Walang acceleration in the x direction. Because bakit? Kasi wala namang force sa x direction. Hindi ka naman nalagay ng force dyan. Di mo naman tinulak yung bola. But since the acceleration is equal to zero, we can just use our usual position is velocity times time. So ang itsura na lang yan, ganyan na lang. So this is just your usual distance equals speed times time. Or nung naalala nyo nung elementary kayo, distance is speed times time. Ganun lang siya. Ganun pa rin for the horizontal component of motion for a projectile. Now, the velocity, since it's constant, edi walang nagbabago sa Vx is the final velocity. It's the same as the initial velocity regardless kung nasaan yung particle. Okay? Same yung initial at final velocities for the horizontal motion, for the horizontal component of motion. Questions? Again, the displacement is just v times time, speed, velocity times time. The horizontal displacement. The velocity is the same regardless at every point in the path. The horizontal velocity. Questions? May tanong ba rito? May tanong? None. Now, paano pag vertical motion? Pag vertical motion, it's accelerated. There's some constant acceleration with magnitude equal to the acceleration due to gravity. And di ba alam na natin yung mga equations associated dyan? Therefore, how can you determine the position as a function of time, or in that case, the vertical position as a function of time, given you have constant acceleration? Alam mo, constant acceleration yan, no? Ano ngayon yung position as a function of time mo? Ano lang yan? Ano lang yan? Eh di, ano lang yun? Remember? Naalala? Ano lang yung magiging position of, what is y as a function of time? What is y of t there? Your y of t is just your position time function na similar sa free fall. Free fall motion lang din yan. So in that case, you have your free fall motion here where v naught is replaced by v naught y to say that this is just the vertical component of the velocity. Dito ay horizontal component ng initial velocity. Now, in that case, you have y as a function of time. What about the velocity as a function of time? Constant din ba yung velocity as a function of time? Constant, hindi constant ang velocity mo dyan. It changes because you have acceleration, which is negative g. Tama? Tama? Gets?
Yes, sir.
Okay, I hope we get it. And therefore, the velocity now is just your velocity time equation similar to free fall. Ang nagbago lang ay indices. Kasi dito, you need to specify now that is in the y direction. You are taking the y component of the velocity because your velocity now is in 2b. Nakuha? Nakuha? Gets ba to? Gets? I hope you get it. Now, sige. Now, hindi pa natin ini-specify paano nga ba hinati yung velocity. So, remember your vectors, right? The velocity here, let's assume that alpha naught, as I said in the previous slides, let's say that alpha naught is the angle between the horizontal and the velocity. Now you can decompose the velocity vector v naught, that's a vector with magnitude v naught, into its x and y components, and therefore we can determine the initial velocity in the x direction, which is simply v naught cosine alpha naught, and the initial velocity along y direction, which is v naught sine alpha naught. Okay? Nakuha? Nakuha? Ang ginawa lang ay dinecompose natin yung velocities, and it turns out that you can replace all the v0 x's and the v0 y's in the previous slide by this. So, yung v0 x, papalitan ko yan ng v0 cosine alpha naught. So, pinalitan ko lang ng v0 cosine alpha naught. Yung vx is just, pinalitan ko lang yung v0 x ng v0 cosine alpha naught. Okay? Whereas for constant acceleration, lahat ng mga v0 y na to, tatanggalin mo yan. Gagawin mo v0 sine alpha naught. So, in that case, you have v0 sine alpha naught and another v0 sine alpha naught. So, ano lang nangyari? Balikan nyo yung kinematic equations niyo, change all the initial velocities there to v0 sine alpha naught, and you're done obtaining the equations that you need for vertical motion. Okay? Questions? Nakuha mo na lahat ng velocity ng equations na kailangan mo. Again, you don't need it hindi nyo nga kailangan mag-memorize kasi open notes naman ang exam, open notes ang FQ. So, just write the equations that you have and you're done. Diba? Kung exam to in the face-to-face setting, you need to memorize. You don't need to memorize, you need to familiarize. Okay? Questions? So, may tanong ba rito? These four equations are important in analyzing the motion of a particle of a projectile. The motion of a particle or the motion of a projectile. Okay? Now, so we can also obtain, so kung napansin nyo dito, lahat to time dependent. Pansin nyo, di ba? Time dependent lahat yan, no? This is time dependent except for this constant kasi yan. Pero to time dependent. Now, of course, as I said kanina, wala ka namang stopwatch sa mata mo pag tumingin ka ng projectile na binato mo, di ba? For example, a baseball, di mo naman makikita agad-agad yung time niyan. But you can trace the path. And it turns out that you can remove the time dependence, the explicit time dependence. You don't remove the time dependence. You remove its explicit, you remove your time in the equations. But of course, all of them are dynamical variables and therefore dependent on time. Pero pwede mong tanggalin dun sa pagkakasulat ng expressions yung time. Ang tawag doon, you are determining the trajectory equation of the projectile. So, pwede nating hanapin yung trajectory equation yan. So, from here, what you can do is just remove time in the equations. So, you can merge the xt and vt into y as a function of, xt and yt, x as a function of time, y as a function of time. You can merge these two by eliminating time to get a trajectory equation y as a function of x. Okay, doon, wala nang explicit time dependence. All nakatago kumbaga yung time dependence. Nakatago siya. Okay, so paano gagawin? So, assume that the projectile starts at the origin of the xy coordinate system that looks like this. Now, from here, if this is the origin, what you can do here is solve for t in terms of x. So, ang gagawin mo, itong t na to, i-isolate mo siya ngayon. So, from x equals, and we will assume na x naught is 0, we will get t equals, so dividing both sides by v naught x, we get t equals x over v naught x. And then this one, alam ko na maraming time dependencies dito. What I will do is to substitute this one to these two and say that, ay nawala na. So substitute here, this here, we get an expression that looks like this. X over v naught x plus 1/2 minus gx over v naught x ulit, 1 squared. Diba? So tapos 0 na lang yung initial position kasi sinet natin na 0 yung initial position ng particle. Okay? Gets? And from that, we can obtain an expression that doesn't have any time in the equations. Wala kang time dyan, no? X na lang lahat yan, tsaka y. And we will see that simplifying, we get something like this. Or in terms of the initial parameters, which is the initial angle and the initial velocity, we get this equation here. This is the trajectory equation of a projectile. And as we see here, ano itsura niyan? Ano itsura niyan? Di ba, y siya as a function of x, tapos yung x ay naka-square. There's a second degree term here. Therefore, the shape of a particle, of the trajectory of a projectile is a parabola. Kaya ganun yung itsura niya, di ba? From the previous, kaya ganyan yung itsura niya. It is a parabola. Therefore, may symmetry yan. Symmetric yan about the vertex. Okay? Clear ba tayo doon? Questions? May tanong ba rito? So yan. This will be important. Some problems, medyo konti lang yung problems na nangangailangan mo ng trajectory equation. But I will show you, if time permits, a problem that can easily be solved using the trajectory equation. Okay? Questions? May tanong ba? Are there any questions? May tanong? Wala? None. Okay. Now, so that's what a trajectory, the trajectory looks like. Initially, you have the initial velocity v naught here, which can be decomposed into v naught y and v naught x. Now, this v naught x, as I said, for the horizontal component, the velocity is constant. Therefore, at any given time, constant lang yung mga velocities na yan. But the vertical, so kung papansin mo, the vertical looks free fall, di ba? And since acceleration is negative, velocity is positive, the tendency of the acceleration is to slow down the velocity, to slow down the particle, and therefore make its velocity as small as possible until it reaches this point here. The point here is your maximum height. The maximum height, ang sasabihin niyan, walang vertical component of velocity. Therefore, dito, wala kang nakikitang arrow na pataas or pababa. Only a purely horizontal velocity. And then after that, since 0 na yung velocity, the tendency of the velocity is to make it negative kasi may acceleration ka pa rin dyan na minus g, hindi naman nawala yung acceleration. So, negative, negative, negative. So, you have a positive large, it decreases in magnitude until it reaches 0. Tapos, i-increase ulit yung magnitude niya. It becomes more negative as it goes down and until it reaches its terminal point. Okay? Ganun yung trajectory equation. Questions? May tanong? May tanong ba dito? May tanong dito? None. Okay. Now, okay, so paano tayo magsosolve ng problem sa projectile motion? Now that we know the equations, we are familiar with the equations for projectile motion, how do we solve problems involving projectile motion? So, here's a problem-solving guide. Una, syempre, i-define mo muna yung coordinate system, as usual. Ganun naman lagi, di ba? You first define your coordinate system, which is positive x, which is positive y. Nasaan dyan yung origin? Ano yung angle between the initial velocity and the x-axis? That's the first thing that you need to do. Always construct first your coordinate system. Because in mechanics, a description of motion starts at the origin or at the coordinate system you're using. Okay? And then second, list down all the variables given and the one to be determined. Which of the quantities is or are not present? Ano ba yung hinahanap? Kailangan malinaw sa inyo ano yung hinahanap at paano kayo makakakuha ng equations para mahanap mo yung variables na meron ka na kailangan mo. Okay? And then after that, okay, here's an important trick para lang, kasi parang dami-dami equations. Isipin nyo lang na pag horizontal component, it's just velocity times time. Therefore, the velocity there should be constant. So pag hinahanap, what is the final velocity or final horizontal velocity of this projectile? Sagutin nyo agad ano yung initial velocity dyan. Because the initial horizontal component of the velocity is the same kung saan man yung trajectory. Pare-parehas lang yan. And then the displacement, x equals vt, the x there or the position, x equals vt, product lang yan nung time at saka velocity. Ganun lang siya. So for the horizontal component, it's just speed equals distance equals speed times time. That usual equation. For the vertical component, you use your kinematic equations. So kung naalala nyo si kinematic equations, yun lang din yung gagamitin ninyo dyan. Diba? Gets ba? Gets? Gets to? Gets? Yun lang yung gagamitin. You use, again, your kinematic equations. Oh, is there any question? There's a question? Okay, gets lang naman. Okay, sige. Now, usually it is time or initial velocity that there is sa two components. Okay. Syempre, yung time parameter yan for both the x and y direction. So, same yung time yan at any given trajectory. So, kung halimbawa hinahanap mo yung final point, you can use, for example, the x component to determine the time and then use time to determine the y component. Usually, ganun yung nangyayaring atake. You start with x, determine the time in the x, then use that time to determine y. Pwede yon. Pwede rin naman kung velocity is an intermediate step, you find first the initial velocity, use that initial velocity for the other component. So, tatulay ka ngayon, ang gagamitin mong bridge dun sa x at saka y components ay yung time or initial velocity at saka initial angle. Because these variables are common to both the vertical and the horizontal components. Okay? Clear ba tayo doon? Malinaw ba tayo doon? So, yon. So, yun agad tignan mo, asan yung time? Asan yung initial velocity? Usually, ang initial velocity given yan. Ang time hindi. Usually. Let's see. And then, after that, solve for the unknown variables. And then check using other equations. Use your sanity check. May mga equations ka na iba dyan. Gamitin mo yon. Or use some physics to understand the problem. Are there any questions for this topic? For this part?
No, sir.
Na.